All right, we're going to continue with this trig stuff. So today's pretty important as well. Okay, this whole lesson, this 12.2, really gets you started on the trig stuff. Up to this point, let's just review very quickly. I'll just draw a little triangle here. A little right triangle. And there we go. So if I knew this angle right here, let's just make it some weird angle. Let's say it's 37 degrees. And let's say I knew this side right here was 5. And then I asked you to find B and C. Would you be able to do that? Yeah, that was the last example we did yesterday, right? First of all, what about, let's call this angle B. Let's call this C, and let's call this A. All right? And if I ask you to solve the triangles, this is a review. We did this yesterday, and you had homework on this too, didn't you? Didn't you have to solve? Oh, I didn't give you homework. Right, I've already collected 12.1b, haven't I?
Yeah.
Did I?
Yeah.
Yeah, I did. Yeah, I'll just turn it back to you. Yep. All right. So anyway, you've done this before, so you should be able to do this now. So what if I asked you to solve for B and C? What would you do? Because you know this angle. But first of all, let's do this. Let's find angle B. That's the easiest one.
90 minus 37.
You got it. 90 minus 37. And what's that? 53? Did I do that right? So that would be 53 degrees. All right, so that's one part of it. That's the easy part. Didn't have to know any trig at all to do that, did you? Nope. All right, let's say you want to solve for B. How in the world would you solve for B? Well, you could look at this angle, 53, since you just found that. Or you could use the original angle that they gave us, which is 37. Let's just use the original one, okay? Doesn't matter which one you use. I could go through and show you that you could use either one, but I'm not going to. It's just a waste of time. So let's just do this 37 right there. So if I want to solve for side B, what do I look for in this triangle? Well, is there a side that I know? Do I know one of the sides?
5.
Yeah, 5. So what is the 5 to the 37? Is it opposite? Is it adjacent? Is it hypotenuse? What is it? This right here, this 5. This 5 is opposite the 37, okay? So we have opposite, all right? So that's one of the things we have. Now, what are we trying to solve for? B, right, which is adjacent. So do we have a trig function or trig ratio, they call them? I'm so used to saying function all the time. We haven't even talked about what a function is, but just bear with me if I say function. Do we have a trig ratio that has opposite and adjacent? It's TOA, which is the what? The tangent, right. So now, it all depends on which angle I'm dealing with, though, okay? So what angle am I dealing with? The 37. So I always take the tangent of the angle. Okay, everybody with me on that? You can't take the tangent of like a side. Okay, you can only take the tangent sine or the cosine of an angle. All right, a lot of people get confused on that. All right, and it equals what? Opposite over adjacent. So look at 37. Which one is opposite 37? 5. And which one is adjacent to 37? B. So now what we want to do is solve for B, correct? So let's do that. We did this, I think, yesterday or the day before, whenever it was. We multiply both sides by B. Everybody see that? Because that will get the B on the top in the numerator. And let's do it in one step. How do I get rid of that tangent of 37? Divide it, because the tangent of 37 is just a number, isn't it? It's a number that you stick in a calculator and some decimal number, all right? So remember, it's just a number. So I'm going to divide by the tangent of 37. And I'm going to take this and divide this by the tangent of 37. Okay? So that cancels, So B equals, we'll just write it nice and pretty here, 5 over what? The tangent of 37 degrees. So you get your calculator out. And of course, on my stupid calculator, I got to do this. And then I got to come back to do radians. All right, so I should be good to go now. So I always have to change it to degrees if I'm using a tangent, sine, or cosine, okay? So let's do this. 5 divided by, so 5 divided by tangent right there of 37. I don't think I have to put an end to the parentheses, but I will just to make it look nice. All right, so hit enter, and there we go. 6 points. Let's round it to just one place. What would it be? 6.6. Right. One decimal place. So it's not 6.64. It's just 6 point what? 6. Okay. All right. So that's what B would be. All right. 6.6. Now, if you wanted to, how could I find C without using any trig at all? I could use Pythagorean theorem, couldn't I? But here's the issue. The 6.6 is not exactly 6.6, is it? Okay? This is an approximation. Would you agree? All right. So it's probably best that we don't use Pythagorean theorem when we're using an approximation. So let's find it to the closest value that we can find. Okay, so let's do trig again. I'm not going to use the 90. Let's stick with the 37. You could use the 53. We're not going to use the 90. You could either use the 37 or the 53. Let's stick with the 37 since we did 37 up here. So which number do they give us that we know exactly what it is? The 5, right? Now, technically, I guess you could use the 6.6, but again, it's approximation, and I'd rather not use an approximation. I'd rather use the most exact numbers that I possibly can. Everybody good? All right. Because what we're going to do is if I put that in Pythagorean theorem and I use an approximation, I'm going to get an approximation for my answer. So that's really 2 approximations, and that's not as accurate as I need to be. Does that make sense? So I want to keep it as accurate as I possibly can. So what are we going to use? The 5 and the C. So this is opposite, and this is what? Hypotenuse. So which trig function uses opposite and hypotenuse? SOHCAHTOA. It's the sine, SOH, right? So, SOH, opposite hypotenuse is the sine. Everybody got that? The SOHCAHTOA really helps out, doesn't it? Yeah, it's super helpful. So I take the sine of what? 37, right? If I took the sine of 53, I'd get something completely different. I'd get opposite over hypotenuse, then I'd get 6.6 over C. Do you see that? All right, so make sure you don't use the 53. Stick with this one right here. So anyway, the sine of 37 is the opposite, which is 5, over the hypotenuse, which is C. The math is exactly the same. Tell you what, once you get used to this, like doing all these steps and canceling stuff out, you almost don't need to do that. Do you see what's going to happen here? Can you do some of this in your head? That C is going to come over here, right? And what's going to happen to the sine of 37? It's going to go... Right, it's going to go on the bottom. All right, so after you get used to these, I don't think you have to go through all these steps right here. Would you agree? So I could just look at this and say, oh yeah, I know how to do this algebra in my head. The C comes over here, the sine of 37 comes down here on the bottom, so I'm going to get 5 over the sine of 37. All right, so let's put that in here. So it's 5, oops, gotta use my, divided by the sine of 37 this time. Sine of 37. Boom. Close the parentheses. And there you go. Yep, 8.3. If I say to round it to one place, that 0 does not round that 3 up, so I just keep it 8.3. Okay? You know what? I don't know. Yep. Shoot. On the, I forgot to change something. I tell you, I think if I do this, is it not popping up? I thought it should pop up. Oh, there it is. Why am I not seeing it then? I don't know. There's something with this program that I use to record. It's not showing the calculator. So if you happen to ever look at the YouTube video, you won't see the calculator. I got to figure out. I thought I had it fixed where you could. I'll have to go through and figure out what I did wrong. But anyway, you put it in a calculator and you get 8.3. I should say approximately. I'm not going to like mark off if you don't put the little squiggle equal sign, but it's nice to do it. Okay, so it's 8.3. And that's what C is right there. Now, do these numbers make sense? Sure, because look, 37 is smaller than 53, so the side that's opposite to 37's got to be the smallest side. Agreed? hypotenuse has to be the biggest side. Is this the biggest side? Yeah. So that's one way to kind of check a little bit, do a little informal check to make sure that you're getting correct numbers. Okay, because, I mean, some people will do this and they'll get crazy numbers. They might put it in wrong, or they put it in radians instead of degrees or something. They'll get some decimal number like 0.0321, or I don't know, just making something up. All right, they might get something like that. And you know this is not going to be 0.0321. Would you agree? All right, so you got to make sure that you look at them. Do these numbers make sense? Yeah, absolutely. They do make sense because that's the biggest one, that's the medium one, and that's the smallest one. So very good. All right, all of that was, let me get rid of this. All of that was review. Here's the situation today. I just wanted to show you the comparison between what we've done before and what we're going to do today. All right, so we're still going to use right triangles. So let's draw another right triangle. Let me get my notes out here so I'm not winging it. I drew my right triangle just a little different than the last one, but that's okay. Oops. All right, let's do this. And let's do this. All right, so here's a right triangle. I'm going to give you kind of easy numbers right here, 3 and 5. All right, I'm going to call this angle A, call this one B, call this one C. Now, what we're going to do today, now you could find the length of AC right here, couldn't you? Should be able to do it in your head, like right now, real quick. What is it? Boom.
4.
It's 4. Very good, because there's a 3, 4, 5 right triangle. Okay, but that's really not the hard part. Okay, we can use that if we want. But right now, what we're going to do, something that you've never been able to do before. All right, and now with this trig, now you're going to be able to do this. Look at this right triangle. I don't know either one of these acute angles, do I? I know it's a right triangle, but I don't know this angle and I don't know this angle. On the problem before, that was 37. So how did I find the other one? Just went 90 minus 37. No big deal. But this time, I don't know what this angle is. But with trig, we are going to be able to figure out what this angle is and what this angle is right there. Sounds pretty exciting, doesn't it? All right, so it kind of is in the math world. It's kind of cool to see how to find this missing stuff. So this is something brand new that you've never seen before. But what we're going to do is use our trig functions. So what we're going to do is, let's say we're going to solve for A first. Okay, we could have solved for B. I just picked A. All right, so let's just pick A. Now, what I want you to do is to look at the two sides that they give us and figure out which trig function are we going to use with the two sides that they give us. So what is the 3 to the A? It's opposite. What is the 5? It's hypotenuse. So say it. We're going to use the sine. That's right. So we're going to use the sine, but this time I don't know what the angle is. Remember on the last problem I put like the sine of 37? But I don't know it's 37. I have no idea what it is. So what do I call it? Sine of A. That's right. So I'm going to write the sine of angle A equals what over what? 3 over 5. It's the opposite over the hypotenuse. Okay, so the 3 is on top and the hypotenuse, the 5 is on the bottom. Now what we're going to do, what I'm going to show you might look a little weird and crazy, but it's really not all that hard. So what is this saying? This is saying the sine of what angle is going to give me the ratio of 3 over 5. So what is that angle? I have to find that angle right there. Okay? Now you might think, and a lot of people mistakenly say, oh, let's just divide by the sine. But is the sine a number? Just the sine by itself. No, the sine by itself is not a number. Okay, I can't just divide by the sine. Would you agree? All right, because it just represents a ratio. It just represents the opposite side divided by the hypotenuse. So I can't divide by the sine. A lot of people want to do that, and they just say, oh, divide by the sine. This, you can't do it. But you can do this. You can take the inverse of the sine. You hear what I just said? I could take the inverse of the sine. It's not dividing by the sine because it's not sine times A. It's the sine of A. So what I can do is take the inverse of the sine. So here's how I do it. All right, it's kind of weird looking, but this is what we do. We put sine. Now watch, don't freak out, but I'm going to put to the negative first power. Now why in the world did I do that? Well, kind of. Do you remember? I don't know. You probably learned this in Algebra 1. Watch. If I had 3 to the negative second, do you remember what to do with that? Yeah. 1 over what? 0? Is that what you're saying? Oh, point. No. You're close, though, at the beginning. 1 over. That is right. So that's the first part of it. Did you do this in Algebra 1? Okay, you just don't remember it. That's fine. So what you do is this. Over 3 squared. So when you see a negative exponent, it just means flip it, right? And then get rid of the negative. Or just change the sign. You with me on that? So what if I had this? What if I had x to the negative first? How would I write that? 1 over x, or just x to the first. 1 over x to the first. Everybody with me on that? What is this? What is x over 1 and 1 over x? They're inverses of each other, aren't they? Reciprocals, we say sometimes, okay? But they're also inverses of each other. So when you take something to the negative first power, what does it really mean? It means you're taking the what? The inverse of it, okay? That's why they use that to the negative first power thing. Okay, we're not going to do this. We're not going to put 1 over x or anything like that. I just wanted you to see where that comes from. Everybody got it? So it's kind of weird, but after a while, you kind of get used to it. I'm going to move this 3/5 over, just give me a little bit of room. So now, if I take the inverse of one side, talk to me, I have to take the inverse of the other side. Exactly right. So what I'm going to do is take the inverse of 3 over 5. And you're like, well, what in the world's going on here? How does that help me? Well, let's go to the calculator again. And I really wish, let's see, I really wish this would show up on my, yeah, it's not. I don't know why it's not. Let's get rid of it. I don't think it's showing up. It kind of acts like it's there. See that blue right there? That represents where the calculator is. So I don't know if that's actually showing up on YouTube or not. I kind of doubt it is. Maybe I have to do this. Maybe I do this. Ah, there it is. But then I got rid of... Then where's all my geometry stuff? Oh, what's this? Oh, I got to do this. Watch this. Whoa, nope, don't want to do that. I don't know. I'm not going to do that. Forget it. Oh, man, I messed everything up now. Now you can't see anything. Let's see. Do I have... Yeah, I got stuff up on there. Oh, daggone it. What did I do? Oh, my goodness. Let's get rid of that. Let's get rid of this. What's this thing? What? No. It looks... Yeah, it is definitely the calculator. Where'd my... Oh, goodness gracious. Oh, man, I messed everything up. Maybe I can Control Z. Oh, there we go. There we go. Okay. Sorry. I'll figure it out. I got to do that at home. I shouldn't do that in front of you guys. But anyway, if you're watching on YouTube, I'm sorry. You won't be able to see what we're doing right here. But I'll explain it to you. Let's right-click on it. Let's hit mode. And then let's go down, change it to degrees. That's very important because it's not going to work right if we don't do that. All right. So now we're good to go. So let's see. This is what I'm looking at right here. All right. The sine to the negative first, or the inverse sine of 3/5. If you look at the calculator, look at sine, and look at your calculator too. If you look at the sine button, you see it? It's probably in yellow or a different color or something. It's not on the button itself. It's actually on the calculator. And it says sine to the negative first. So how do you get to that sine to the negative first? What do you think? You hit the second function. That's right. Okay, so watch what I do on my calculator. And yours might be similar. So you hit second function. Mine puts a little up arrow on it. Then you hit sine. See how the calculator already puts sine to the negative first? So that's the inverse sine. The inverse sine of what? 3 divided by 5. So I put 3 divided by 5. I like to close the parentheses. And then we hit equals. And guess what it just gave me? It gave me the angle. Now, the other problem, it just happens to come out to 37, right? Or 36.9, which is almost 37. The other problem, when I had 37, I just made that up off the top of my head. So I'm kind of surprised. Anyway, there we go. So let's move this over, get this out of the way. Let's get this out of the way. So what is this angle right here then? This angle A, is about, what is it? 30. Yeah, let's round it to, let's go 1 degree. Let's measure it. I'm sorry.
Announcements for today.
Let's go 1 decimal. Okay. So what's that going to be?
Just a reminder to
36 point what?
Seniors will not be here today, so please mark an
degrees.
SA. Also, tomorrow is professional development, so students, you do not have school tomorrow. Just a reminder, no school for students tomorrow. Congratulations to the girls' varsity soccer team for their victory over Odyssey Charter. The middle school girls soccer team, you have a dismissal of 1:45 today. You'll be departing in the upper school lobby. Middle school boys lacrosse, you have a dismissal time of 1:45, and you'll be leaving at 2:10 for the Lions Den. JV baseball, you have a dismissal time of 2:10. Thank you. Have a great day.
Okay, so let's do the same thing. Let's find out what this is. Now, if this is 36.9, this should be what? What's 90 minus 36.9? Probably what? 57.1 or 50? I'm sorry, not 57. 53.1. Yeah. So that should be 53.1. Agree? All right. So let's do the trig stuff, but let's find B using the trig stuff, and let's use the original numbers that they give us. I could have put a 4 right here. Okay, and I could have used any of the trig functions, couldn't I? Okay, I could have used adjacent over hypotenuse. I could have used opposite over adjacent, right? I could have used any of those, but let's just use the numbers that they gave us, all right? So let's now solve for angle B. So let's do it. If I solve for angle B and I've got the 3 and the 5, what are the 3 and the 5 to angle B? This is adjacent, this is hypotenuse. Which trig function is adjacent and hypotenuse? Adjacent and hypotenuse? Cosine. All right, it's the cosine. So this time it's the cosine of angle B. Agreed?
Yeah.
All right. So, and that's equal to what over what? 3 over 5 again, right? You're like, Mr. Hamrick, it's the same exact thing. Well, it's not, because this time we took the sine of it, right? And this time we're taking the cosine of a different angle, all right? So, but they both equal 3 over 5, adjacent over hypotenuse in this case. So what do? How do I get B by itself?
Cosine to negative.
Yeah, take the inverse cosine. That's how we're going to say it. Okay, I take the inverse cosine, but we write it cosine to the negative first. And then I'm going to come over here and do what? Take the inverse cosine. Okay, and now it's set up for me to get B by itself. Remember, I didn't show this, but look, the inverse sine and the sine basically cancel each other out. The inverse cosine and the cosine cancel each other out. So I'm just left with B. Right? And now we can put this in our calculator. You try it. So second function cosine, then 3 divided by 5, 3. And I'm just doing it this way with the trig function just to show you that it should come out to what we thought it was going to come out to be. Yeah, there's your 53.1, just like we said it should be. Pretty cool, huh? So this is 53.1 degrees. So that's angle B. And right there, there's angle A. There's my 2 answers right there. Pretty cool, huh? So now look at that. Here's the first time in your life you've ever had a triangle and you've had 2 missing angles, and you're able to actually find those missing angles. Now you had to know a couple things. You had to know 2 sides of the right triangle. Okay, you didn't even have to know all 3. You just had to know 2 of them, right? And then you can do all that stuff. If I knew all 3 sides, I could have used any of the 3 trig functions that I wanted to. Would you agree? If I had all 3 sides, but they're not always going to give you all 3 sides. You could always find it though. This one came out super easy because it was a Pythagorean triple. It was a 3, 4, 5 triangle. Let's do one more example and we'll quit. Is that all right? I'll keep the calculator there. All right. We're going to draw a right triangle. And we're going to put some different numbers in there. This is not going to be a Pythagorean triple, so it's not going to be quite as pretty as that one. But really, it's not going to be really any more difficult. except for finding the side. So this is going to say solve the triangle. Okay, solve the triangle. All right, so solve triangle ABC. What does that mean? It just means find all the missing parts. Well, here's what they give you. They give you that's 11, and they give you that's 17, and that's all they give you. So I got to find everything else that's missing. So what's missing? Well, side AB is missing. And then, right, so angle A, angle B, and the hypotenuse. So those are the three things we have to find. We know everything else. Agreed? All right. So where do you want to start? Yeah, let's do AB. Let's do Pythagorean theorem. So we know how to do that. So AB squared is equal to 11 squared plus 17 squared. I'll do the math for you. I've already done it. It comes out to the square root. This is weird, but it comes out to the square root of 410. And I don't know if that simplifies or not, but they allow you to just put it as a decimal. So we're going to put that into our calculator, and you get approximately 20.2. Okay? All right, so that's what that is. Now, when we do our little trig stuff, I'm not going to use 20.2. Why not? It's approximate, okay? It's not exact. Let's use the exact numbers that they give us. Is that okay with you? Now, we could use it, and we could still get pretty close to the answer that we're supposed to. But sometimes it might be off a decimal or two. All right, so let's just use the numbers they give us originally. What do you want to solve for first? Angle B? All right, we'll solve for angle B first. So which trig function are we going to use if we're going to use angle B? Opposite over adjacent, which is the tangent, correct? So we take the tangent of B is equal to the opposite, which is 11, over the adjacent, which is 17. Now, let's get B by itself. What's that going to look like? It's going to look like the inverse tangent of 11 over 17. It's really not that hard, is it? It seemed like it was hard at the beginning, right? With that inverse thingy. But really, it's not that big of a deal. So what do? I come over here, hit second function tangent, hit 11 over 17, 11. Make sure you know how to do it on your calculator. Okay, don't just look at mine, because yours may possibly be different. And I'll talk about that in a second. And then 32.9, yep. So we should put approximately, squiggle, 32.9. And that's an angle, so it's in degrees, correct? So angle B is approximately 32.9 degrees. Okay. We could, to find A, we could just take it away from 90, couldn't we? All right, and that'd be fine. If it was a quiz or a test, I'd be perfectly fine. If you find this one, then go ahead and just take it away from 90, and you got that one right there. But since we're learning this stuff for the first time, let's just, for the fun of it, actually do some trig to find angle A. Is that all right? So let's see if I can give myself some room here. Okay, so let's find angle A this time. There we go. This one right there. So which trig function are we going to use? We're still going to use tangent, aren't we? So this is going to be opposite over adjacent. But now the opposite is 17 instead of 11. Now the adjacent is 11 instead of 17. Okay? So I'm still going to use the tangent, but it's going to look a little different. So the tangent of A is equal to what? 17 over 11. Right? Now, in order to solve for A, I take the inverse tangent, very good, of 17 over 11. I won't take the time to put it into the calculator, but you should get 57.1. Do you?
Yeah.
And that's exactly what you would get if you would have taken that away from 90. Everybody see that? All right. So really, if it was a quiz or a test, if I got one of these angles using the inverse trig function, I would just find the other one just by taking it away from 90. That's what I would suggest to you. The only reason I did the trig twice is just so we could get an extra, I don't know, whatever you want to call it, extra practice with it. There's still one more little section we need to do on this, but I think we've done enough for today, don't you? Yeah. And since you got a long weekend, I'm not going to give you any homework, Okay, I'll give you the homework on Monday. All right, so I'll assign it on Monday when I finish teaching the lesson. So, no homework. Okay.